Hello, welcome to Engineer's Mindset. Now, let's say we are given the problem and we are asked to find partial z partial x and partial z partial y for the given function z equal to the whole of this variable. Okay. Now, to do this, first thing first, this is what I will do. I will say let u be equal to the whole of this variable, which is simply 2x squared y plus 2, and let v be also equal to the whole of this variable, which is x y squared minus 2y squared. So I have this. So I'm calling the whole of this variable to be what? U, and the whole of this to be v. This now implies that z itself now is simply equal to, in place of 2x squared y plus 2, I will simply have u, and in place of xy squared minus 2y squared, I'll simply have v. So this now looks like what? Product function u dot v, which means I'm going to employ what? The product rule to solve this partial derivative. Okay, so the first thing says find partial z partial x, and you know from product rule that partial derivative of z with respect to x is simply equal to, so we said keep u constant, differentiate v with respect to x. So we have keep u constant, differentiate v partially with respect to x, plus, now you keep v constant, so plus v, then you differentiate u partially with respect to x. So we have partial u partial x. So this becomes, that's a rule for product derivative. Okay. So that's a rule for product partial derivative. Okay. Now, we know what u is. We know what v is. So which means all we need to do is simply obtain what? Partial derivative of v with respect to x, and also partial derivative of u with respect to x. That's all we need to do. Because we know u to be this and we know v to be this, we now need to find out their derivative with respect to what? X. All right, so let's try that and see. Let's start from u. From u equal to 2x squared plus, um, from u equal to, we have 2x squared y plus 2. So I need to only what? Differentiate u partially with respect to what? X. So partial u over partial x. And I said partial derivative simply means differentiating a function with respect to a given variable, keeping the other variable attached to it as what? Constant. So I want to differentiate u partially with respect to x, which means I'm going to be keeping y as what? Constant, because I don't need y. Y becomes a constant. So I'm differentiating u with respect to x. I will be keeping y as constant, and I will always treat a constant the same way I treat it when I differentiate a normal constant like 1 or 2. Okay, so I want to differentiate x, and from this side I have 2x squared y. So 2 is a constant, y is a constant. Keep them aside. I simply have 2y, because I'm not differentiating with respect to 2. I'm not also differentiating with respect to y. So keep them aside. Then you differentiate x squared. Of course, if you differentiate x squared from the rule of differentiation, I will simply have what? 2x. That is to say, use the power 2 to multiply the variable x. Then subtract 1 from the power, so it becomes 2 times x, then 2 minus 1, which remains 1. Alright, so if I differentiate x squared, I will simply have 2x. So I have this. Okay, now this is a constant on its own, plus 2. 2 is a constant on its own. It does not contain any variable of x. And you know, if I differentiate a constant, I will simply have what? 0. So that means the derivative of this man is simply plus 0. So this simply implies that the partial derivative of u with respect to x alone is simply what? 2 times 2 here is 4. So I'll simply have 4xy. So I have this. That becomes partial u partial x. Okay, so this part of the formula has been solved. I know partial u partial x. Now I need to find what? Partial v partial x. So I also recall from v, okay, from v equal to, we said let v be simply xy squared minus 2y squared. Okay, equal to xy squared minus 2y squared. Okay, so I differentiate v also partially with respect to only x. So which means I'm keeping all the y variables as what? Constants. Here I have x attached to y squared, so simply treat y squared as a constant, so you keep it aside, differentiating only x. And if I differentiate only x, I will simply have what? 1, because x here is raised to the power of 1. Okay, so if I differentiate x, I will simply have 1. All right, that simply gives me 1, okay? Minus, of course, here, 2 is a constant, y squared is also a constant, and there's no x variable attached to it. So if I differentiate the both of them with respect to x, it becomes 0, because they do not contain any x variable attached to them. So therefore, their derivative becomes what? 0. So I simply have this 0, okay? So therefore, partial v, partial x, okay? So partial v, partial x simply gives us what? Y squared times 1 is simply what? Y squared. So I have this. Now, I know partial u partial x to be this. I know partial v partial x to be this. I can now plug it into this equation and obtain the partial derivative of z with respect to what? X. So let's try it and see. Partial z partial x is simply equal to, we said, hold u, and the value of u from what we assume is that let u be equal to 2x squared y plus 2. So we'll put down the value of u, which is 2x squared y plus 2, okay? Differentiate v with respect to x, and the v, the x simply gave us y squared, so simply multiply by y squared. So we have this plus, next we said hold v constant, and the value of v is given as this xy squared minus 2y. So we simply have xy squared minus 2y squared, okay, minus 2y squared, okay. Then differentiate u partially with respect to x, and we obtain the u, the x partially as what? 4xy. So simply multiply here by 4xy, okay. So that becomes the partial derivative of z with respect to x. So we may wish now to expand the bracket and see if we can collect like terms or anything at all can add or subtract from them. Okay, so if we do that, we have partial z partial x is now equal to, let's expand the bracket now. Of course, 2x squared y multiplied by y squared simply gives us 2x squared y cube. Okay, we have this. Same thing here, 2 multiplied by y squared simply gives us plus 2y squared. Okay, here we have xy squared multiplied by 4xy, and that will simply give us plus 4x squared y cube, okay, x squared y cube. Then we have minus 2 y squared multiplied by 4x y. That will simply give us minus 8 minus 8x y cube, okay. So partial derivative of z with respect to x is now equal to, so let's check now. I have 2x squared y cube here plus 4x squared y cube. So the two of them can add. 2 plus 4 simply gives us 6. So that simply gives us 6x squared y cube. Okay. Okay, I think that's all I can add. So I have plus 2y squared minus 8xy cube. Okay, so this becomes the partial derivative to that function with respect to x. All right, so you may wish to want to factor out x, okay, y, because there's y in all if you wish, but this can also be taken as the answer. All right, so the second part of the question says find the partial derivative of z with respect to y. Okay, so it means we have to now change the order of the formula. No longer going to be partial z partial x, but what? Partial z partial y. That means it becomes partial v partial y, and this becomes partial u partial y. Let's try it and see. All right, so to find partial z partial y, since we also here is a product function, we know that partial z partial y, now we are differentiating with respect to y. From the law still, keep u constant. So I hold u, differentiate v with respect to now y, plus you keep v constant, Now you differentiate u partially with respect to y. So you have this. So we know the value of u, we know the value of v. All we need to do is simply what? Differentiate v with respect to y, differentiate u with respect to y. That's all. So let's now consider when u is equal to 2x squared y plus 2. From u equals 2x squared y plus 2. Okay, we need to differentiate u partially with respect to y, because that's the first thing. Find the u dy. Now we want to differentiate this function with respect to y, which means I'm going to be considering x as what? A constant, no longer a variable. So I'll keep x as a constant and differentiate only y. So every treatment I will give to a constant, that's the same way I'm going to treat s. All right, so here I have 2x squared y. I want to differentiate y, not x. So simply keep 2x squared. Since I have 2x squared attached to y, keep them aside, they are constant. Then differentiate what? Y. If I differentiate y, I will simply have 1 because the power of y here is simply 1. So if I differentiate y, I will simply have 1. So that gives me 1, okay? Plus, if I differentiate 2, 2 is a constant. And since there's no y variable attached to it, that derivative becomes 0. So I'll simply have plus 0. So this simply means that the partial derivative of u with respect to y is actually what? This is simply 2x squared. So we have this. So this part of the equation is settled. Next is to find partial v, partial y. So we consider from v equals, v was given as xy squared minus 2y squared. So from v equals xy squared minus 2y squared. Now I need to find partial v, partial y. Differentiate v with respect to y. So like I said, I will keep every variable that contains to x as what? A constant. Okay, so I have here x. X is treated as a constant, so we keep it as. I want to differentiate y squared. To differentiate y squared, simply use the power to multiply the variable. So I will simply have, this is simply what? 2y. So y squared is actually, so the derivative of y squared is actually what? 2y, okay? Because I'll have 2 times y, then subtract 1 from the power, 2 minus 1. That simply gives me 2y to the power of 1, which is something as 2y, okay? Minus, okay? Here as well, 2 is a constant, so keep it out. But this 2 is attached to what? Y squared. So I need to differentiate y squared. If I differentiate y squared, just like here, I will also have 2y, okay? So this becomes times 2y. So I have this. All right. So partial derivative of v with respect to y is now equal to, of course, if I expand this bracket, I will simply have 2xy minus 2 times 2 here simply gives me 4y. So this becomes the partial derivative of v with respect to y. So I know the v dy, I also know the u dy. I can now plug into this equation to obtain partial z, partial y. Okay, so partial z, partial y is now equal to, first thing, we said keep u constant, and the values of u simply give us okay, u is simply 2x squared y plus 2. So we simply have 2x squared y plus 2, keep u constant, differentiate v partially with respect to y, and partial v partial y give us 2xy minus 4y. So simply multiply 2xy minus 4y. So I have this, okay, plus, next is to what? Next is to keep v constant, okay, and v is actually xy squared minus 2y squared. So we have xy squared minus 2y squared, and then differentiate u with respect to y, and the u dy simply give us 2x squared. So we have times 2x squared. All right, so at this point, you may wish to what? Expand the bracket and see if anything can add or subtract. So let's try that and see. Partial z, partial y is now equal to, so 2x squared y multiplied by 2xy simply gives us 2 times 2 here is 4. X squared times x simply gives us x cubed. Y times y gives us x squared. So we simply have 4x cubed y squared. So we have this. Same thing, 2x squared y multiplied by 4y. 2 times 4 is 8. Y times y is y squared. So we simply have minus 8x squared y squared. So we have this. Okay. Next is 2 times 2xy. 2 times 2xy, and that is simply 4xy. So plus 4xy. And finally here, plus 2 times minus 4y simply gives us minus 8y. Okay. Here we have xy squared multiplied by 2x squared. That simply gives us plus 2x squared y squared. And finally, we have minus 2y squared multiplies 2x squared. That simply gives us minus 4x squared y squared. So we'll check and see if anything can go. All right, so partial z, partial y is now equal to, so I have 4x cubed y squared. Okay, there's no x cubed y squared here. So we'll keep it aside, 4x cubed y squared. Okay. Next, I have minus 8x squared y squared. I have here plus 2x squared y squared. I also have here minus 4x squared y squared. Okay, so of course, I can evaluate all the terms in x squared y squared, x squared y squared, and x squared y squared. So minus 8x squared y squared plus 2x squared y squared actually gives us minus 6x squared y squared. Then minus 4x squared y squared actually gives us minus 10x squared y squared. So we simply have that to be minus 10x squared y squared. Okay, that's off. Next we have 4xy minus 8y. Okay, so we'll bring that down, plus 4xy minus 8y. Okay. All right, so this becomes the answer to that partial derivative. All right, guys, I hope you find this video very, very educative and interesting. Please, if you do, I would like to hear your thoughts in the comment section. Do well to hit the subscribe button if this is your first time on this channel to get more updates on contents like this. I will see you in the next video. Thanks and cheers.